Okay. Hello, everyone. I'm Mehdi. I am a PhD student at the University of Waterloo. I did in my undergrad biomedical engineering, and then I really liked robotics a lot. So I did mechatronics during my master's, and then I switched to system design in my PhD. And so right now I'm going, and the project of my PhD is the continuation of my master's. And so right now I'm just going to be really going through my project since my master's all the way to right now what I'm currently doing. So my goal is really to talk about how we can assist older adults to stand up and move, and that's something really a problem as you grow and with all the issues you have, health issues you face over time. And so very, very common issue, which we really don't focus on much. Very common issue older adults is standing up. When you stand up, you need to use many muscle in your body, and you have to use multiple body segment coordination in order to fully lift yourself up to a standing up position. And this is hard. As you grow older, as you know, your cognitive ability decreases, your physical ability decreases, and so like really research showed that 41 or 40% of the falls have of the falls because of inappropriate sit-to-stand transfer, and that could lead to hip to like a hip injury or knee injury or any other injury. And as you grow older, you really don't have much time to actually get better. Once you're injured, you're gone. Well, hopefully not, but it's very hard to heal. And so we really need to solve this issue. And so there is so many existing solutions to help you stand up. And so the common one are you could call it the walker or the rollator, those two rollators, but none of them provide like physical or active assistance. All of them, they just put your hands and then you let your body weight lift them up as much as possible. The other ones, they exist in the hospitals and you cannot use them at home. And so that's an issue. We need to have a solution to help older adults to stand up. And so there are so much research into that, how we can use it. There is the exoskeletons where you have to wear it, but the challenge with that is that any older adults want to use it, they have to wear it. Someone else have to help them wear it, and they're extremely uncomfortable. If you wear them, like you will really hate your life. It's there's a lot of metals. The motors control your leg. It's not good. The second one they are using for rehab, and that's very good. However, you cannot use it for in houses and very hard to use and complicated. And so we want to have really when I started my master's, I looked into all of them, into all those devices. Like, okay, we really need to have an assistive device that can help older adults stand up and walk, because that's the ultimate goal. Well, when someone stands up, they're standing up to go to somewhere to do something. So we need to have that in one device. And so when we figured out my need statement, I formulated my objective, which is to build a novel, lightweight device that can help user have the ability to stand up from any sitting position, and this is very important, in a different environments, meaning indoor and outdoor, and then encourage them for walking. And so after talking to doctors, I'm not gonna bore you with all the questionnaires I had already, all of them. I talked to doctors, nurses. I asked health adult experts on how are we supposed to assist older adults to stand up? And after talking so much to them, they told me that the best way to assist older adults without having any harness around them, without attaching anything to any robot, part to the user when standing up, is they have to put their hand on the handle fully straight, and your arm has to be fully straight, so you can transfer the load from your knee and your legs all to the shoulder. And this is very important. You might say, oh, you might have weaker shoulder, but they said most of the adults, they don't they're able to actually transfer that. And so if you look at the sitting, I don't know if you can see me all the way in the back, your hands really have to be like that. So if you have anyone at home who really wants to stand up, that's the best way to stand up. It's just make sure they're fully straight, and so the load can transfer to the three joints over here, and so they're able to stand up. And so that's what they suggested, the best way to stand up. I'll tell you something at the end. But so I came up with this design. So I have one handle to lift. So because I need to have the handle very low, at very low height, I have two handles. I'll show you how it works. So this goes all the way down, and then so once I go up, I have I put my hands on an upper handle for walking. Imagine if you have very big tall sticks walking around with it. It's very hard to control the robot, and that's why we have this two-level system handle, and I'll explain to you why. So yeah, so the robot can provide active, horizontal, and vertical supports that move forward and lift you up, and then you can control it using voice, and then using the camera as well, which I'll be talking about. I connected it to Alexa, so you can control it fully using Alexa. Really, my goal was to have it in the hospital. You are in one room, you could call, "Hi Alexa, can the robot come to me?" And then it has the navigational capabilities to navigate through the rooms and arrive to you to help the older adults stand up. So this is a scenario we imagined for senior homes. I'll be showing the results for you guys over soon. But so I did a lot of experiment in motion capture lab for healthy subjects. So as you can see over there, so that's the skeletal model we built for health, for for the human and of the robot. We wanted to analyze how much forces is being applied to the robot. Like, is the actual robot useful? Like, how much load are they adding on it? And then we looked at the kinematics of the user to make sure, are they safe? And so here, just to show you how the robot works. And so the robot move forward and lift up the robot at the same time. We added the markers on the user over here just to analyze their body, like body joints, angle, and everything. So as you can see, the robot move forward and lift up the user at the same time. And so you might we really, when we were doing this, we wanted to see how, is this actually safe? Because there's key things here is that, before I move over here, there is one point you guys say, and a lot of you might have a question about the go back. All right, so the robot is moving away from the older adults as standing up. This is dangerous. So whenever I was building the robot, I wanted to make it as lightweight as possible because it's foldable. Older adults can carry it. So that's a constraint I added on myself for no reason. But so for the horizontal thing, I made the robot move forward. And this really was a big concern because it's moving away from the user. What if the older adult falls? And so we had to do a lot of experiments on that with healthy subjects, and I'll talk about the clinical trials I did later on. But so we tested the robot a lot. As you can see here, when I was designing the robot, really key things that I wanted to use it in anywhere. So I made the base and the chassis of the robot so low so it can go under any chair, under any bed, and wide enough to make sure it's good, while I kept the dimensions of a normal rollator in within the normal things. And so we tested that on buses, we took it to trains, we took it everywhere to test it out. Does it assist older adults? Let's say they go for a walk. That's a problem. If they sit down, they can't stand up. So can it assist them in anywhere? And so we took it everywhere and we tested that. And so we showed that it's capable of doing it. It's good. So it's safe. And really, it's challenging when you take robot outside of the lab. That's where things break. It did not break, so it's good. And so here, just really quick. I don't know why I stopped. Okay. So here, the user is talking to the robot. It's just we wanted to show that you could control using voice control. So we set it up to say, I want to stand, and then it helps you the robot stand up fully. Now, I'm just gonna give very quick point about it. Alexa is great. The reason why we chose it is because it allow you, it's very easy to program it and allow you to have, as I mentioned, I want to have Alexa in every single room. That's at least the scenario we had in our head when we're doing this research. I was talking to Prof, and so you chose Alexa, and every Alexa has its own ID, and so you could, if someone called Alexa from room 2, we know it's coming from this Alexa. Now, is it useful? I'm just gonna very quick thing. Definitely, it's useful. But then, is it easier? Is it easy for older to use? Would older adults choose to use it? I would say no. We have the results. You'll see there's a lot of things we built, but then it's why? So there is one over here thing. The robot is able to navigate to where the user is. So if it goes to a room, it sees the user, the robot will go there, and then it will help them, it will see them. So it's like, yes, it's tell them, yes, I'm coming, and then here the robot comes to them, and then you do work with them. So we added all those features. So this is at the end of my message. So that's where like, okay, we built this novel device. What can I do with it more? So during my so this was something like I wanted to do from long ago. We have all the city-stand trajectory you saw was predefined trajectory. What does that mean? We did a lot of experiment to figure out how the user is supposed to stand up using the robot, and this is all on simulation, all using pure math. But we never like, so we are assuming that the user will place their hand vertically like this at all time. But what if they don't do that? What if they do that? What if they do that? Right? It's very, very hard to like, especially for older adults, to tell them something to do and keep focus on it. And so we wanted to add a system that can monitor the user's action at all time during sit-to-stand. What if they fall, right? That's important. And so we added a camera with an AI model in it to track the user's position at all time. And you can see the landmarks on the body user. And so we're looking at the user, what are they doing? How are they standing up? Are the like each landmark supposed to go in a certain position? Are they following those position or not? And if they're not, it reacts in real time. And so we added a fall detection system. I'm not gonna go in details how it works, but then there is an interrupt that makes sure the user, if they fall, we get the user. And so here, as you can see, the AI model, I'm looking at myself here, I fall. And so it saw that, like it jumped, it saw that fall, and then it reset its position to help me stand up. So using Alexa, we actually could trigger, because I have Alexa, it came handy now. It's useful finally. We can trigger like, oh, someone fall, you could call the nurse to come and help you. And so that's for fall detection. But however, as I wanted to have the ability for the robot to have a customized motion for each person. The way I stand up is different than you, and you. And especially for older adults with having muscle weakness, that's an issue. And so I wanted to have the ability for the robot to help the user stand up adaptively. I don't want just predefined trajectory at all time. And so that's where my research work. And so the robot over here, it looks at my body and they always evaluate how I'm standing up. Let's say I'm healthy, I could stand up faster. And then it will speed up and make sure I'm healthy. And so you could standing up in a healthy way. That's my ultimate goal, is to how we can mimic, let's say, a healthy subject like inshallah forever like me, as able to stand up, right? How can I mimic that? How can I make the robot mimic that? And you can see here, if you look at the natural sit stand over here, I recorded myself, so you can see there's cameras all around me. So I'm always doing it in motion capture labs. You can see that the green one is the adaptive one, and which is like, react to my motion in real time. While the predefined is over here in purple, and you can see that the adaptive one is much closer to the natural one compared to the predefined, and that's good. I want to mimic natural sit stand. When I'm assisting someone, I don't want to make them fully reliant on my robot. That's very important. I forgot to mention that the robot is only supposed to provide 30 to 40% of their total body weight support. That if you provide 100% of their body weight, or even higher than that, that's mean they're physically not allowed to talk, and they you lifting the user up like more than 50% of their body weight could mean that there's a high chance that they're gonna fall as they walk by themselves. And so the robot, like when they build this robot, it's only supposed to support this amount no matter what. And so here we're showing that we're supporting around 40% of their body weight, even less, 35. And then we're able to mimic real-time sit-to-stand trajectory, like adaptive one, real-time sit-to-stand trajectory, and it's really similar to the natural one over here. And so that's really was a key in my research. It's like we need to have this adaptability for every user. Imagine if I have a one trajectory for hip for a guy with a hip surgery or a knee surgery or someone else. It's endless. So this is something we did. And so I really wanted to discuss with you, this is a different thing, but the pilot study I did the clinical trials, it's been a year. and I had to fly all the way to Germany to do it. Canada was hard. They don't give you anything. To be honest, one of the things I want to say, the only problem with medical technology is that getting ethics approval, and that takes forever. There is a lot of paper back and forth application you have to do. And I just went to Germany 2 months, it's done. So over here, so as you can see, we do it in a motion capture lab. Move on. Okay, so this is like an older adults doing sit to stand. Okay, so older adults over here. So the 3D starter model are coming from the camera. So right now we use a newer motion capture lab. We don't have to add all the dots on the user, the balls. And so right now it's just using AI to generate the skeleton model and to generate the kinematics we want to look at. And so we did the clinical trials at the hospital Germany. I really can't present the results yet because I just finished it in December. However, the results were useful. The results showed we did a lot of interviews. We did a lot of, I think, 7 different surveys. We did structured interviews. We had to collaborate with the University of Heidelberg to actually do all those social questionnaires, which I'm not expert at. I'm a robotics guy. And so a lot of work went into it. But there is one key thing that is the sad the video is not here. We did a lot of proper clinical trials. There's one thing that you figure out at the end is that through all those questionnaires, the robot was useful, right? It helped them. It made them really stand up. But then when you told them, would you actually buy it, right? That's the main thing. Would you actually buy it home? It's like, no. Why? It's just too complicated. Even though the robot looks very simple, they just have to place their hand. They have to charge it. It costs a lot of money. And even said it's safe. They just prefer the rollator they have it for, that has been around for 100 years. It's just simple. It's not costly, and it's just they said literally, we will use the minimum amount of whatever is existing there that does not require effort or any cognitive ability. We will use that. We will never use robotic device like that. I'm like, thank you. I spent 5 years working on it. It's gone. But then, to be honest, I was lucky to do the clinical trials at a rehab hospital. So I had a lot of hip surgery people who just had surgery a week ago, and then just coming here to learn how to stand up again. So I learned. So I had access to that pool of subjects. And then right now, the last year or so of my PhD, I fully transitioned to rehab robots now. So no more assistive robots, but that's very good, to be honest, because my goal was to actually help older adults and anyone to stand up and to have it a lightweight, very small robotic. So I had the ambition, okay, I want to build a robot to to help people stand up from a bus station or anywhere. But right now we saw that it's really not needed. You learn something that it's like if someone is able to stand up, right? They will use the whatever walker out there. They will never use a robotic walker, but to help the people who really need help, who are just recovering from surgeries. And so that's, I think, where really I'm going for. And so that's the end of my presentation. I talked a lot, but hopefully you had questions.
Have you considered that? Thank you for thoughts. Like that user of your device is not the customer. I mean, because you'd have that customer be an insurance company, a hospital, and the user would be someone who needs it more than the usual walker. And so it's not the same thing for the user and the customer.
Yeah.
And I guess through this journey, you thought you were going to do one thing, but this journey transforms you, so you know more, but you ended up doing something else. And I think maybe it's that process of exploration, discovery has its own reward. So even though you kind of succeed in the original definition, still I think that's valuable advice. And say, well, I'm a robotics guy, I'm not doing a customer survey. I mean, all these kind of surveys and getting a approval, ethics statement, all that. I think it's kind of valuable experience.
Absolutely.
I think great.
Yeah, just to say, the robot, as I mentioned, it's just would they buy it? No, I said that's that's where the answer. But then it is actually assisting them. It is helping them. And I think if you can see the way I built the robot is that I built it in a way that it's very easy. It's like a Lego parts. To remove part, add a part, and then you can add as many sensors as you want. And so right now, it's being used a lot in other studies as well. So just because I moved on to a different thing, that doesn't mean I use it. And to be honest, when I started my master, I never thought I want to do PhD. It's like too much. But then hey, look, start. And so that's what happened when you stay in academia. You never leave. Yes.
I have a question about this figure specifically.
Yes.
So you see how the natural sit to stand is actually much shorter than both the
Correct.
adaptive and the predefined. Do we want, so I wanted to ask you, is it good for the one that you're building to be longer? Or like, is it intentionally longer than the normal sit to stand? Or was this measured using actual elderly people, how long they take to
Yeah.
stand? Or was it you, like, how was this figure developed?
Absolutely. So the predefined takes longer time, right?
Yeah.
And so the reason why it takes longer time is because we looked at how older adults stand up and how long they usually take to stand up. And so we took that into consideration, and then we implemented on this that's how they're supposed to stand up. However, as a healthy, so I did this experiment specifically on a healthy subjects. Healthy subjects stand up much faster. And so when I measured the natural sit to stand was based on a healthy subjects, and then the adaptive one was trying to react to that, to my speed. Now, your question is that is it always better to have it faster? No, because older adults might stand up slower, right? And so it might be it might take longer, but the main thing is that the adaptive one is able to react to my speed. So if I am the guy who's able to stand up this fast, if the robot can react this fast to me, it will be able to react to older adult speed. And that's really the main thing. So here we're just showing that it's able to react to my speed, even though I literally should stood up really quick. But the main thing is that the adaptability to the user motion. It could be older adults, children, fast, slow. As long as it's adapting, it's good.
I think it would be helpful for, like, when you're portraying this information, to maybe have like one for like you know, control subjects, like you healthy people, and then one for actually old people, and see
Yeah.
it adapts to both. And so like,
Yes. Like I really wanted to do that here. Maybe that's a different presentation, different round, but like the older adults data, like just the whole, like I don't think I could do it in 10, 15. I'm not allowed to share it yet as well, because we just finished in December. Yes.
My question is about the training part, where you said the device like learns how you move, how you stand up. So because different people can have different injuries, the different way they can stand up, right? So how does the machine learn it in the first place?
Actually, so we're looking at the landmarks, right? So like we look at each landmark, right? We look at so for sit to stand, I don't care about those. I care about the knee, pelvis, shoulder, and then the arm over here. So because I want it to be straight no matter what, right? And so we look at those positions, right? And then I have like computer algorithm. I have a feedback controller. Is that each landmark supposed to follow a specific thing? Is it following it or is it not? If it's following, that means it's good. So the user is using the robot correctly, standing up correctly, right? If not, then it slows down. It's like, it changes how much it moves forward, lift up. So it makes sure those landmarks are exactly there. So it's not really AI. It's just with the only AI part is just figuring out those landmarks. The other one is just feedback system.
So does the user have to do it multiple times, or is it one or twice?
No, it doesn't matter. Like once directly, just shows
Okay,
you.
just once.
Yeah, because again, we're not training it on the user. Just look at the points. Yes.
Okay. So when you were asking older adults whether they were willing to purchase such an assistive device, did you observe any differences between users who have been using like walkers for say 1 year, a few months, versus those who have been using it for 10 years, maybe 15 years?
So everyone we have been using. So during our exclusion criteria, they had to do multiple tests in order to choose them when they're doing the experiment. So for example, can they walk? One of the two exclusion criteria is like, can they walk on their own for 5 meters and going back and forth? And so we had like really selective people on how long they have, like who can actually participate in the experiment. So even if an older adult uses a walker, but he could do all those tests, he would not be in the experiment. And so to answer the question directly, I don't know how much, but they are very very reliant on the walker. We never ask how long they have been using it, especially because when you're asking older adults, like doing experiments, really getting older adults to come and try your robot, that's a whole mission and so on.
Yeah,
Not so many of them.
Because I thought also that maybe these people are familiar already, too familiar to their device with their devices. So they won't be willing to change, even if your device presented more advantages, like
Absolutely.
cookies.
Yeah, that's definitely the case. Like they're used to it. They could be that like one of them telling me is like, okay, so in Europe they don't have all of them elevators. It's like how all buildings. So how can you actually carry it, right? Even though it's not much heavier, even if it's foldable, they really prefer to have this one. Like again, like what you have right now out there is just literally like aluminum tubes with wheels stuck together, like very light, very simple. The complexity charging, all that, motors, the sound when the motors make, all of them play into account. Even if you use brushless motor, even if you reduce the sound so much, still factors affect it.
What was the most fun and the most challenging part of this project for you?
Maybe let's not talk about it. So during my master's, so during COVID time, so it started in 2020. So I was like, very ambitious, like, I want to build a device that can help everything. So as you can see, I want to have the ability, like, you're not allowed to attach anything to the user, use it indoor and outdoor. I want to help everyone. So it was very hard. So really talking to like figuring out how we're supposed to stand up. That was a mission and so on, because I had to talk to so much doctors, because I don't want a harness. I don't want anything. Like, those existed. If that's the case, I'm not creating anything new. You see what I mean? They existed. And so after that, then they told me, oh, this, then I had to figure out how to combine, how to actually build a system that is lightweight. Like, it's
So that
doable.
was the challenge, right?
Yeah, designing.
The most fun.
Most fun? I don't know. Are we recording?
Well,
Well, to be honest, doing the clinical trials in Germany, to be honest, like, it's true that I have been working on this project for 4 years, and I was just able to actually test it on older adults, and then I actually built a completely new robot after my experiment. So I finished it in December, and then after the clinical trials, after I saw them talking, as I said, I moved to rehab, and like not fully similar idea to help them stand up and walk, but I fully changed the robot. So this semester I completely redesigned the whole robot. Like it's finally giving you satisfaction. It's like you tested it out, now you can move on with your life. Before I did not. Yes.